nice to be here. First time I'm actually giving a talk in a theater with a balcony, so that's pretty cool. Nice to meet you. My name is Ives van Hoorne. I am Dutch, but my name is even hard to pronounce in the Netherlands. So you can call me Ives, you can call me Ives. My friends also have trouble with my name. They call me Flip. If you want to call me Flip, it's fine as well. You can find me on Twitter or X under the name CompuIves, 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 well, the drill. I am one of the 2 co-founders of CodeSandbox. And I couldn't see just now. I'm curious how many of you have used CodeSandbox before? Okay, that is great. And it doesn't matter because I'm still going to give a demo of CodeSandbox. So, can you see CodeSandbox? Yeah, so this is CodeSandbox. CodeSandbox is an online development environment. It essentially allows you to write code in the browser. And the main goal is that you can share a link with someone else, and they will be able to see the executing code. And if they want to make their own change, they can press fork, they will get their own link, and they will be able to continue working. And today, I want to talk about this part of CodeSandbox, the preview, because that one has changed a lot. The React ecosystem and the dev servers that run React applications have changed a lot over time. And CodeSandbox is nowadays pretty old. I got a beard in the meantime, and well, it's from 2017. And CodeSandbox started in 2017, and that was also when Webpack was most popular. It was the way to build your single-page application. But at the same time, people also found it a bit frustrating because you had to use all these loaders, these transpilers. You had a big configuration that you had to get started with. And if you wanted to get started with your React application, well, you had to configure it. And that made it less accessible for people to get started. So quickly after, Create React App was started. And Create React App took the opposite side. They said, well, no, you need to be able to start everything with 0 configuration, and we also don't give you a way to configure anything because this is enough to start a React application. And that was great. It quickly became the default for a lot of people to start a React application. Under the hood, it was still using Webpack, though. And people noticed that if the application would get a bit bigger and bigger and bigger, the dev server could take a while to start. It could take 2 minutes, 3 minutes, 1 minute. And then suddenly, out of nowhere, ESBuild appeared. And ESBuild is created by Evan Wallace. And I have so much respect for this person because he was at the time also the CTO of Figma, co-founder of Figma. And he built ESBuild, which is an alternative to Webpack, but is written in Go. And the thing that blew my mind here is that it's not 10 times faster than Webpack. It's 100 times faster than Webpack. Faster than anything I would have believed initially, and a lot of people in the JavaScript community also didn't know that something like this was even possible, to build a web application in 1 second instead of 100. So now you can see a lot of tooling that is talking about writing it in Rust or Go because of what ESBuild has shown. And one of the interesting dev bundlers that came after using ESBuild is Vite, created by Evan Yu. Is there anyone here who's named Evan? No? Okay, because if there were, you're bound to do great things, or you've already done great things. Vite is literally fast in French. And it is a fast bundler. It's much faster than a lot of alternatives. And it uses ESBuild under the hood. And it also uses modern browser technologies like ES modules. And the great thing is it works with React, it works with Vue, it works with Angular. It's very broad in what it can support. So Vite is a very interesting tool, but then in the React community, you also saw that there was this movement. You were already able to server-side render React, but could you make it more seamless? Could you define a component and then make it seamlessly render on the server and then hydrate it on the client and add dynamic logic to it? And so because of this, there were also frameworks that made this easier, and those became popular too, like Remix and Next.js. They made it easier to do server rendering. They made it easier to run more code on the server side. And it's not that these tools are new. Next.js, I think, was already out there, maybe even before Create React App. But they are gaining a lot of popularity because of the fact that we are moving a bit more to the PHP days. I'm not saying we move to PHP, but it's getting closer. So CodeSandbox started with just Webpack, and we just wanted to run Webpack. But over time, the bundlers changed, and I want to talk about kind of what runtimes we have built in the meantime, how those runtimes work to run this kind of code, and also how you can use those runtimes to, for example, build interactive documentation, or if you want to build a course, an interactive course, then you can use it too. Or if you want to build a CodeSandbox competitor, that's possible then too. So let's start with the story. The story started in 2017. I was a student, and I had just worked a while at a company, Katowiki, and I noticed that it was pretty hard for me to collaborate with my coworkers on code when we were not in the same room. Like, we were sharing code snippets on Slack. And I was thinking it would be cool if I can share a link to a web development environment. And so that was the initial idea, but we were students. So we both together, my co-founder and I, we had 50 euros a month to spend. And we were talking about building an online development environment. And initially, we were thinking, oh, then we need to run the code for the user. But with this amount of spend, that's pretty hard. And JavaScript was getting more and more powerful. There was more and more things running in the browser. So I was thinking, could we maybe run this kind of application in the browser? And the first try was putting Webpack in the browser, just compiling Webpack to the browser, replacing file system, replacing everything. But as you can imagine, that got pretty big. The bundle size was 60 megabytes at the time. There was also no parallelization, so it all happened on the main thread, and it was pretty slow to load. So it was pretty slow in general. However, Create React App was getting more popular. And this was very interesting to me because the amount of permutations that you can have with Create React App is 1. You don't have all these configuration options. So you just have to support Create React App, and then it will work. And so I was wondering, could we maybe build a bundler, like a dev server, that runs in the browser and is built to run in the browser? And then we use it to emulate Create React App. And people would then think that they are running the real Create React App on CodeSandbox, but they're not. They're using our bundler, and it's just emulating Create React App. And that is how Sandpack was born. An in-browser bundler. And we were running this for a year, and even a year after, we were able to host CodeSandbox on a Volter VPS, and we had about 500,000 monthly users on $40 a month because we were just executing everything in the browser. Most of our spend would have been bandwidth, but Cloudflare, so that made it free for us. So I want to talk about how this works. Let's say we have an editor, and we have an iframe. In the iframe, we run the actual dev server. So that is the bundler. It's also running on a separate domain for cookie reasons. Whenever you make a change in the editor, we do a post message to the iframe and send all the code. Then the iframe will do the dark magic, and it will send back the results. Now, to really understand what that dark magic is, I first want to talk about what a JS bundler does, like a normal JavaScript bundler like Webpack. There are really 4 stages that a JavaScript bundler has. First one is discovery. You give it a file, and it goes through all the import statements, finds those files, goes through those import statements, and it builds up like a dependency graph. Then you have transpilation, which means it will convert the files to browser-readable files. So, for example, TypeScript to JavaScript. Then it will link everything together. It will combine all those files into one big file, or if you have a smarter bundler, multiple files with code splitting. And finally, it will do optimization, where it will minify all the code, and it will do static analysis and then remove the code that's not needed. So that's how a JS bundler works, but we are running things in the browser, and we really are building a kind of an in-browser runner. And because of this, we don't need linking because all the files are already in the browser. And we also don't need any optimization because we're running dev bundles. Instead of those, we need to run evaluation. And evaluation is essentially running the code. So I built a mini CodeSandbox in CodeSandbox, which you can find here. It's written in React, and this is the code to make it work. But you have this input where you write your code, and that's this one. And then you have this output where the code is put in, and that's this one. And whenever the input code changes, we call it use effect, and we use Babel, which is a transpiler, to transform the code to browser readable code, essentially. And then when you click on run, that's what we do here, we will run eval. So everyone says you never should run eval. Even we say it here with the ESLint rule. Eval can be harmful. And we built a business on it. And that's one of my greatest achievements. But I can change code here, and you can see it update here. And also when I press run, it will execute the code. So that's great. That's the first version of CodeSandbox. That was also the first version that we had when prototyping this. Let's look at how we can support multiple files. When you have this JavaScript code and we transpile it, it turns into this code. And that is pretty interesting because it now calls a function called require. And this function is not special. We can override this function, and then it will call our function. So that's also exactly what we do. Instead of just evaluating it, we now also define a require function. And when your code calls require, it calls our function. And that function will do exactly the same thing that we were just doing now, where we take the JavaScript, we transpile it, and we evaluate it here. And that is in my mini CodeSandbox 2, which you can see here. It's the same code, really, but we now have an object of files. And you can open these different files. And we have here an import statement, import greet from greet. And you can see it requires greet here. And all of this is the same. We still have the transform code and the update files. But the main difference now is that we use this function to run the code. And this function gets a list of files, which is essentially these files, and what path it needs to run. So it finds the code, it transpiles that code, and then it uses the eval again, and it defines these globals, exports and modules, so that the code can export. Like you can see here, I do export const greet, and in transpilation, it becomes exports.greet is greet. And require, so that we can so that we can run the code again, and it's recursive. So if I run this, it should work. It works because of the import from greet. I can also make this a change to this greet thing, and I can run it again. And now that change should also be in here. So essentially, we define a require to be able to support multiple files. And you can do this too. I mean, this version of CodeSandbox, we've been running for such a long time, and it's fast. It's really fast. Like I have here a small video of where I'm showing like React, but we're also doing a lot of module reloading here. Because of the simplicity, we can do a lot of optimizations here. And you can change like CSS and it updates live. You can change the use effect and it will reflect it. You can even change all the text in here and it will keep on updating while the use effect is updating because of the fact that it's so fast. It's like, yeah, it's executing immediately. So this is in a library called Sandpack. It's open source. You can play with it. You can use it. You can use it to build your CodeSandbox competitor or use it for live documentation. For example, the React documentation, all the live examples, they are powered by Sandpack. So if you want to use this, feel free. What are the pros and the cons? Well, it's fast and it's cool because we can use web workers to do parallel transpilation. We'd also do code splitting to only load the bundler parts that we need. So we use a lot of web technologies for that. There's also shared caching. Like if someone opens the sandbox for the first time, we will send that cache that they generated to our server so that the next user who visits that sandbox won't have to do transpilation because another user in the world already did that for them. We also have full control of execution, which allows us to build a lot of custom CodeSandbox features, but it's still emulation. If you want to do more, if you want to go outside of the box and do custom Webpack configuration, our bundler doesn't support that. So we had this. We had a way to run create React app. And then people started to ask for more. They started to use CodeSandbox for more. And one of those requests was VS Code themes. And I was thinking, sounds like a good idea. We already have a theme provider. Let's replace the tokens with the VS Code theme. So we announced theme support in CodeSandbox. And you could import your VS Code theme, and it would work in CodeSandbox. And then this was the following tweet. And that one is a bit more involved. It sounds like, oh, you already have themes, well, then extensions must surely work as a next step. It's not that easy, especially at the time, VS Code didn't run in the browser. Today it does, but at the time it was only a desktop application. But when you think about it, VS Code is based on web technologies. So initially I dismissed it, but then I started thinking, could we maybe fake Node.js in the browser? so that VS Code will think it's running local on a normal computer, but we're actually running it in the browser. And that is the second iteration. That is what we started working on next after Sandpack. An in-browser Node.js emulator, essentially allowing you to emulate a Node.js environment so that programs think that they are running in Node.js, but in reality, they're running in the browser. We use this to run the VS Code editor and VS Code extensions. And if you think about it, it does make sense because Chromium and Node.js, they both use the same JavaScript runtime, V8. The main difference is in Node.js, you have web APIs like fetch, XML, HTTP, request, service workers, web workers, and Node, well, it has Node APIs, child process, FS. So what if we slowly move over those to this side and emulate all of them so that people will think that they're actually in a Node.js environment? That's what we did. We took those Node APIs, and there are quite some Node APIs, and we made a browser version for all of them, but not for all of them, because there were also a lot of open source solutions already which had an in-browser version for a Node API, for example, Buffer or Assert or Path. There were browser versions available because we're not the only ones who want to run Node in the browser. However, there are some challenging modules, and I want to highlight one, which is child process. Child process is pretty interesting because with child process, essentially, when you call child process.spawn, it will spawn a new Node process. So how do we do that in the browser? We spawn a web worker, essentially. When child process.spawn is called, our version of child process.spawn will spawn a web worker, which boots, then we'll send all the files and some WASM from the main thread to this worker, so it's synchronized in state. Then it sends back, I'm ready, and then we say, run this child.js file. And then we do a bit more plumbing, but the interesting thing is we use an in-browser runner here as well that's inspired by the one that we used for Sandpack 2. Interestingly, we are kind of reusing a bit of code here. So this part, I also have a little demo of this, because this is called Nodebox now. You refresh so that you have it here. And I'm showing this also in a CodeSandbox demo. But here you have Nodebox imported from Nodebox, and then we connect to the emulator, and we initialize a file system with package.json, main.js, and the most important logic is in chickensoup.js, as it always is. And in the chicken soup starts an Express server or HTTP server. And in here, we call child process.spawn chicken soup, although we don't call it right now. But if I uncomment this line and I save, then you can see here it opened port 3000. And in here, you can now see that it's returning kind of this Node.js code, but all of this code is running in the browser. I can also do reload frame, and well, you don't see it because it's local, but it's the HTTP, Node HTTP server is responding. So this allows us to really emulate like a Node.js environment in the browser. And you can run it yourself. If you're already running Sandpack, we have some templates that automatically use Nodebox. And we also have Nodebox in of itself, which is nodebox.codesandbox.io. And I want to highlight that Jasper has been great. He's been working a lot on Sandpack and Nodebox, and none of this would have been able to get to the state of what it is today without his help. So I wanted to give credit. And I do want to show quickly that we are, in fact, running VS Code here with all the extensions. Like there are lots of, even a PHP extension, TypeScript extension. And you can also see the child process work here because we are spawning a lot of workers for these little, for example, the client extension host worker, the TypeScript worker, to get these extensions to run. But they think they are in a Node.js environment, but they're not. Cool thing is we can run servers and CLIs in the browser. There's no server cost, there's low latency, but it's still emulation. So if Node.js would release version 20, then we need to keep up to date, make our API work exactly the same. And because we don't define anymore what a user runs, it can also be slower. Like if someone uses, for example, SIMD operations, like that works very fast in Node.js because it uses the certain CPU parts. Maybe it doesn't work as fast in the browser. So that's an important distinction. So I wanted to put a graph in here that would be worse than a graph at an Apple keynote, and that is this graph. I'm not sure if you see that it's a graph, but this is a graph. It's a graph of the amount of people, amount of projects that have been imported in CodeSandbox from GitHub. Because we now had this VS Code that run in the browser, we can run create React app. People started to really use it for more things than only examples and prototyping. They started to use it for real development. And the biggest one that I found interesting is Excalidraw. I'm not sure how many of you know Excalidraw. Yeah, that's great. It's a whiteboarding tool, and it started on CodeSandbox as a sandbox, then got exported to GitHub, and people used CodeSandbox to create pull requests. But then people noticed that in CodeSandbox, the ESLint plugins ran a bit differently than in local environments, because we're in the end emulating things. Sometimes things don't run exactly the same, and so they moved away. And we started to think as well, we wanted to have this, we saw people starting to use CodeSandbox for full development, but we were not even using CodeSandbox to do development ourselves, because we were running a lot of different things in CodeSandbox. We used Postgres, Elixir, Go, Redis, Docker Compose, Docker, Rust. I'm going to talk for a long time because that boat, I can only go to the next slide until that boat is at the end of the slide, the Docker logo. And in the end, with CodeSandbox, we want to make it easier for people to get started with code. Like for prototypes, it's important that you can go to a link and immediately see what you're working on, but it's also important for like development. Maybe a designer wants to see how the code is running. So we were thinking, can we make it also work for bigger projects? And that brings us to the third execution environment, Firesnap. I thought of this name for this conference. I just thought it would be far more fun. And in this, there is a big change. We're actually running code on the server now. We're not running code in the browser anymore. We're using so-called micro VMs, Firecracker micro VMs with snapshot and restore. And I want to talk a bit more about that one. Because when you think of running code on the servers, and you think about Webpack, and you think about the fact that you want to have fast forks, how does that compute? So far with CodeSandbox, you can create a new fork within 1 second and immediately get going because we're able to reuse caches and everything. How can you do that with a server? If your Webpack server takes like 1 minute to start before you can even get running, every time you press fork, you will have to wait 1 minute. That would have been nice. So, oh yeah, I added this beautiful animation. Completely forgot about it. There's turtles, and now you should see this. Whoa. That is our dev server. So we started thinking, what if we don't have to start at all? Like, what if we don't have to start the dev server when you go to a branch, or you go to a development environment, or you go to a sandbox? And the big inspiration is this man, but no, it's more the laptop. We already have this technology. When you close your MacBook and you have a dev server running on it, and you open it a day later, the dev server will just continue running. You don't have to wait for the dev server to start. And it makes you happy, just like him. So we were thinking, can we make that work for VMs too? Like, you have a VM running Next.js, and then we snapshot it, disk plus memory. And then when you come back a day later, we resume it. And it will continue exactly where it left off. And that is what we built. But the challenge is that the first version was very slow, because when you run a VM, it has like 4 gigabytes or gigabytes, it doesn't matter, or 16 gigabytes of memory. And loading even from a file system that's super fast, like an NVMe drive, you can load with 1 gigabyte per second. So we use another technology to enable fast snapshot loading, which is called user file descriptor. It's a feature from the Linux kernel. And it's unfortunate, the thing is already saying, watch your time. So I'm not going to talk about this, how this exactly works, but I've written 2 blog posts about this. One is how we clone a running VM in 2 seconds, and the other one is cloning micro-VMs using user file descriptor. But essentially what this does, it allows us to compress our memory snapshots and load them on the fly, which is very interesting. Like, if a VM needs 400 megabytes to resume, then we will only load those 400 megabytes instead of 4 gigabytes of memory. And compressing memories is very compressible. It compresses to like 10 times smaller. So for example, if you have 4 gigabytes of memory, The memory snapshot is 400 megabytes. And we load, this also allows us to create live VM clones. And if I have time, I will show you how I do this with a Minecraft server. But first, to describe the VM's pros and cons. We can now run anything, and that is very, very cool. If it runs on your laptop, it probably runs on CodeSandbox too. And it can connect with any code editor. We now have a VM running. You can connect with your VS Code. You can connect with your IntelliJ. You can connect with our web editor, with our iPad app. It's, yeah, you can run anything. And it's fast in the sense of we run everything on servers that have an i9 in them, which are faster than an M2 Max. And the cool thing is you can change the configuration, say like I want to go from 4 to 16 cores, and without restarting the VM, we automatically give you those specs. And it's easier to share. Like if you have an issue with your terminal, for example, then you can share a link with someone and they will be able to see your terminal. But the challenge is managing VMs is hard, so we had to spend a lot of time building that infrastructure. And there's also latency, so we also have to open data centers in not open data centers, but use data centers in the US, in the EU. But these are the 3 runtimes that we now have at CodeSandbox and that we use. Sandpack and Firecracker are open source. Notebook's runtime is unfortunately not. But you can check them out. The question is, what can we do with this? And that is what I want to highlight. I have a bit of time, right? 5 seconds? Well, the demo is longer. OK, I'm just going to try. So let's imagine a scenario where you have a development environment running on the main branch. And I want to show you how it would work locally to also show you how CodeSandbox tries to solve these kind of things. So you have your development environment connected to the main branch. And let's assume that everything is already set up. You have your npm install, npm run dev. I want to start working on a new branch. I want to refactor, and I want to convert all tabs to spaces. And generally, that's the kind of work that I nowadays do as a founder, the only kind of work that I do. So I create a new branch. I start working on it. And then I commit everything. And I check out main because I want to work on a new feature. Now I want to add semicolons because I'm a big semicolon fan. So I create a new branch to add semicolons. But then an angry coworker pops up. They like tabs more than spaces. And they also found that there was an issue with the code. To now go to that branch, I will have to, well, stash my work and then go to that branch and run npm install and npm run dev in case that new dependencies are installed. And that is the kind of thing, that context switching, where you have to switch your local file system to pull requests. That's what we want to solve. Because in the case of CodeSandbox, because we are able to snapshot your VM, we run a development environment for every branch. Every branch will have a VM running. Whenever a new commit comes in, we wake that VM, apply the commit, rerun the dev server and everything, and then we let that VM sleep again using this same snapshot technology. So that if you just want to quickly check out the branch without moving away from your local environment, we already have a development environment that's running, and you don't have to wait for it to boot. And you can connect your own editor to it too. You can connect your VS Code to it. You can connect CodeSandbox to it, or our iPad app. And it's also important to mention, this is not replacing your local development environment. You can also still work in your local development environment if you want to. But every pull request will at least have like a running deployment preview, and it will have a running development environment that you can use to review or quickly make changes. And this works with Docker, Docker Compose, all those kind of things. And I want to show that flow. I have a CodeSandbox here. And it's funny because did you see that it loaded? That it resumed from a snapshot just now. That's what I'm proud of. Anyway, this is our CodeSandbox website, and it's running in CodeSandbox. You can see I'm in the main branch. And now I want to make a change. I want to change this try for free to edit for me or something. This is one of the features that we have for Next.js applications. Oh, wait, I need to actually refresh, I think, because the inspector didn't load. OK. This is a feature that we have for Next.js applications where you can click on components, and we'll take you to their code, to the code of that component. So you can immediately make that change if you quickly want to do that. And I can say like edit for me, for example. And as you can see, the moment I started editing, we cloned the VM that we were currently looking at, created a new VM, and also created a new branch. So I don't have to think about stashing my work when I'm making edits on the main branch to move it to a new branch. We automatically create a new branch for you if you're editing in a protected branch. I can verify here that it's good. And we also have a bit of AI stuff in here. I'm hoping it's loading. Yeah, it's a refactor header, change driver free button text to edit for me. So that's one of those AI integrations that we have. We also allow you to chat with the code base here. I can commit and push this. Another interesting thing that we do here is we also, since this branch is it's draft/jolly Carson, after the first commit, we also use AI to suggest a new branch name that you can rename to. I can create a pull request from here. I can create the pull request. Yeah, the time's up. Okay, I don't think we're going to do the Minecraft demo anymore. But now every pull request will also have a link that you can use to edit the code or open it in VS Code or open the preview directly so that you can use it to review. And that's the kind of flow that we want to make easier. That was my demo. And if you want to learn what's next up, talk to me. I have stickers. You can find me on Twitter under the name ComputeIves, and there's also the CodeSandbox Twitter. Thanks a lot for listening.
All right. Thank you, Ives.